Now we're going to look at what is called a state and transition model, and we're going to be building this model up over time. These models are excellent ways of understanding what's happening in an ecosystem and getting the essential processes that we need to understand about that ecosystem to be able to manage it well. This state transition model will be looking at the different ecosystems that occurred in the Lorax. The first ecosystem was the pristine truffula forest. As you remember, the pristine truffula forest is an old growth forest, has not been externally impacted in any way from any onslaught. It has high biodiversity with intact populations of barbaloots, swami swans and hummingfish, and low levels of water and air pollution. And the second ecosystem is the impacted truffula forest. The intermediate state, which is the impacted truffula forest, also still has viable populations of barbaloots, swami swans and hummingfish. It has reduced tree numbers because some of the tree resources have been removed from the forest, but its biodiversity is still viable. It still has existing viable populations of barbaloots, swami swans and hummingfish. And the third ecosystem was the cricklegrass ecosystem. So let's come back to our state transition model, which describes the different types of ecosystem states that occurred in the Lorax. Here we want to start building on that diagram to start giving us a greater understanding of what's actually occurring to cause and influence these different ecosystem states. And so if we look at the transition from the pristine truffula forest to the impacted truffula forest, what we can see is that the driver of that transition is the harvesting of the truffula forest itself. It's possible that if harvesting rates had have remained low, as they were at the beginning of the Onslaught migration, then the natural forest regeneration of truffula trees might have kept pace or exceeded the rate of harvesting, and the forest could have remained in an impacted state but in a relatively healthy state. But what happens in the transition between the impacted truffula forest and the cricklegrass ecosystem is critical. First of all, we get an increase in the intensity of harvesting. And beyond that state, we can see that the forest has transitioned into this completely unrecognisable system called a cricklegrass ecosystem, where no truffula forest exists, and in fact not even a single tree exists. If we come back to our state transition model, we can start building a greater understanding of what's happening here, especially in terms of resilience thinking and systems thinking. In our previous discussion, we talked about feedback loops and how feedback loops were really critical in either keeping a system stable, or if those critical feedback loops were altered, then being the linchpin that then allows an ecosystem to transition into a completely new state. And when we look at the Lorax and what's happening at the ecosystem transitions in the Lorax, we can see there's an absolutely crucial feedback loop that we need to understand in order to manage this system and understand the transitions between different systems. Where we have this process of increasing the intensity of harvesting, it's not really that process in itself which is the critical feedback loop. What's really crucial in this system is actually the extinction of the barbalutes, and that's the critical feedback, because what happens is the barbalutes themselves digest the truffula tree fruits, and that digestion process in itself is responsible for making the seed viable in that it can then regenerate. And so the barbalute and the extinction of the barbalute was a critical process which drives forest regeneration. And once the barbalutes were extinct, that ability of the forest to regenerate itself collapses completely, and that feedback loop of the truffula fruit falling to the ground, the barbalute eating the truffula fruits, digesting the seeds and allowing them to regenerate, that whole feedback loop breaks down. And so we can see that this cricklegrass ecosystem has also got incredibly high resilience, and it's a very stable state. And it's very difficult to be able to move backwards towards an impacted truffula forest, and even less so to a pristine truffula forest, because there's no ability for the truffula forest to regenerate. And so when we look at these transitions between the different states in our diagram, we can start looking at how stable they are and what are our abilities to manage them. And we can start putting some information here. It's obviously quite possible for the ecosystem to move in this direction. And if harvesting ceased altogether, you could probably have an impacted truffula forest moving back to something that looked very similar to a pristine truffula forest. But because this cricklegrass ecosystem has such a high resilience, or is such a stable state, it's almost impossible from a management perspective to move back to an impacted truffula forest, because that critical feedback loop has been broken.